Hi everyone, in today's lesson we're going to talk about solving systems of equations in three variables. What is a system of equations in three variables? Well, what you're solving for is you are solving for the intersection, if any, between three planes. Now, planes is something you spoke about in geometry. I want you to look at this picture right here, and I want you to look at this orange square. This orange square or rectangle would be one plane. This blue one here, back here, would be another. And then this green one would be your third. And now you can see that this point right here is where all three planes intersect. So just like we talked about with lines, this is a consistent system because it has one point of intersection. But now if you look at these three planes again, they're intersecting at a line. This line is their point of intersection. Okay? And then if we look down here, these are inconsistent systems. Inconsistent systems are systems that don't intersect at all. This first example is the most obvious. They're parallel to each other. They're never going to intersect. This orange plane intersects with the blue plane and the green plane independently of each other, so there's not one single point, like here, where all three intersect. Same for here, this green and blue plane intersect here, but what about the orange? The orange isn't there at all, so therefore there are no intersections between all three. So you may be asking, how are we going to solve this stuff algebraically? It's not that bad, but I want us to realize that we are going to be solving algebraically all systems that have one point of intersection. That's it, just one for now. So let's look at an example and see how it goes. Just so you're aware, I have steps down here of how to solve algebraically if you ever should need it. I'm just going to walk you through it right now. Okay. This problem is going to take pretty much the whole page, so try to write neatly and organize yourself. So the first step, we have these three planes, plane 1, plane 2, plane 3, and we want to find where they intersect. So with the first step, you want to take any two equations and rewrite them here to the left. Now, you can pick any two equations that you want, but for consistency, I'm going to pick the first two equations, and I'm just going to rewrite them. So 4x minus 3y plus z equals negative 10. Now you may think it's funny that I'm putting a little slash through the z, but if you start writing z 100 times, you're going to start thinking it's a 2, so I would put the slash through it. And then I'm going to write the second equation below it. And what I want to do is I want to solve this system using elimination. Now we can either eliminate the x variable, the y variable, or the z. We always focus on the x first, so pretend it's just a two-term thing. All you would do is the same thing as regular elimination. So we're going to multiply the top by 2 and the bottom by negative 4. So we're going to distribute everything out in the front and then everything on the bottom. So let's write the two new equations below. 2 times 4x should be 8x. 2 times negative 3y is negative 6y. 2 times z is just 2z. And then 2 times negative 10 is negative 20. Now we're going to write this equation after we multiply it. So negative 4 times 2x is negative 8x. Negative 4 times y is negative 4y. Negative 4 times 3z is negative 12z. And then negative 4 times 0 is just 0. So now, just like we've done in the past, we're going to solve this equation by elimination. So 8x plus negative 8x cancels. Negative 6y minus 4y is negative 10y. And 2z plus negative 12z is negative 10z equals negative 20 plus 0 is negative 20. So what you just did, I'm just going to repeat the steps, is we took the first two equations and we rewrote them down here. And we solved this system by elimination, and we eliminated the x values, and we were left with a new system with y and z. Now what we're going to do is we're going to take the last two equations and we're going to write them to the right over here. So we're going to take 2x plus y plus 3z equals 0, and negative x plus 2y minus 5z equals 17. And we're going to solve this system. And we're going to eliminate the same variable that we eliminated here. So here we eliminated the x's, so here we're going to eliminate the x's as well. So if it helps, maybe we could write eliminate x and then here eliminate x. You always have to eliminate the same variable. So let's do that. So this equation has a 2, this has a negative 1, but notice how we always flip them and make one negative? Well, this is already negative, so all we have to do is flip. There's no need to make a negative now. So we're going to put parentheses. We're going to multiply, this is technically a negative 1 down here, so we're going to multiply up here by 1, and we're going to multiply down here by this 2 here. Now again, just to reiterate, I'm not putting a negative on either one of these because I already have a negative here, and that'll take care of the canceling. So now let's multiply everything out, and then multiply everything out in here. Alright, so pause the video and see what you get. Okay, you should get 2x plus y plus 3z equals 0, negative 2x plus 4y minus 10z equals 34. Okay, now we're going to eliminate. So we're going to add these two equations. So what is 2 plus negative 2? Cancel. What is 1y plus 4y? You should say 5y. 3z plus negative 10z, you should be saying is negative 7z equals 0 plus 34 is simply 34. Okay, so just to recap, we took the first two equations, solved the system, got a new one. We took the last two equations, solved the system, got a new one. Now what we're going to do is we're going to take these two new systems that we just got and we're going to make them, combine them, and have our own system. So negative 10y minus 10z equals negative 20, and 5y minus 7z equals 34. And now we're going to eliminate the y variables. Notice how we're getting rid of the x's at first. Now we're going to get rid of the y's and solve for z. So pause the video, see if you can eliminate, and resume to get your answer. Okay. So this top equation up here needs to be multiplied by 5. This bottom equation here needs to be multiplied by 10. Notice how I'm not using the negative 10 because one is already negative, so they'll cancel regardless. So we're going to distribute all these pieces. You should have gotten negative 50y minus 50z equals negative 100. And the bottom, 50y minus 70z equals 340. Now we're going to add these two equations. These will cancel. I'm left with negative 120z equals 240. Divide by negative 120. We now have a z value. So when you divide 240 by negative 120, you'll get that z equals negative 2. We found one of the variables. Now we need to find the other two. So here's the fun part. You may choose to plug in this z into either this equation or this equation. I don't care which one you choose. I'm going to choose the negative 10y equation. So let's rewrite it down here. So you have negative 10y minus 10z equals negative 20. And now I'm going to substitute z equaling negative 2 everywhere I see a z. bring down everything else. So negative 10y plus now 20 equals negative 20. Subtract the 20 on both sides. So negative 10y equals negative 40. Divide by negative 10. Y equals 4. So now we found the y value. So now the last thing that we need is our x value. So you may choose any one of the original equations now to find the x value. So I will write down here original equation. Pick one of the 3 original equations. I'm just going to pick the one that is on top. So 4x minus 3y plus z equals negative 10. So again, I'm going to plug in z and y. So 4x minus 3 times y, which is 4, plus z, which is negative 2. And I'm going to simplify. 4x minus 12 minus 2 equals negative 10. Combine my like terms. Add 14. 4x equals 4. Divide by 4. X is equal to 1. So you just found their point of intersection. Okay, let's recap all of this. So the first thing that we did is we took the first 2 equations, we wrote them down here to the left. Then we took the second 2 equations, wrote them down here to the right. And we solved both of these equations by elimination and got rid of the x values. Once we did that, we got 2 separate systems, this system and this system. Then we put these 2 systems together on top of each other, eliminated the y variables, and by doing so, we were able to solve for z. Then we chose any of these 2 equations that we got from step 1, and we substituted the z we just got. So I picked this equation. So we substitute the z in, and we get y equals 4. Then I picked one of the original equations, so I chose the top original equation, and I substituted my z and y, here and here, and got an x value. Alright, let's try one on your own. Okay, so I want you to do this one entirely on your own. See if you can model the steps that we did in the first equation, and then hit resume, and the entire answer will be shown. Okay, this should be your answer. So I'll go scroll down to the end so you can see. So your x value should be 2, y value negative 1, and z value 1. If you did not get that, the answer is written here. I want you to look at it, but I also want you to see the process that I did. So pause the video if you need to copy down this information, but I want to show you what I did. I took the first 2 equations and wrote them down here. I eliminated the x values by using the elimination method, and I got a new system. Then I took the second 2 equations and I rewrote them here, and I used elimination to get rid of the x's, and I got a new equation here in red. Then I took these 2 equations and wrote them on top of each other and created a third system. So we've got one system here, another system here, and I created these 2, solved this system, and actually didn't create a system, but I got an answer. The answer is z equals 1. Then I could choose either this equation or this equation to substitute it into. I chose this one. So I plugged in z equals 1 into here, solved this whole thing, got y equals negative 1. Then I went back to the original equation, which is this guy up here, one of these 3 original equations. I chose the top one, and I rewrote it down here. And then I substituted the z and the y here and here, and I solved this equation for x. Okay, so I'm going to move back up to the front so you can see it. And again, pause the video to copy this down. Now I'm going to scroll down so you can see this piece and pause the video if you need to copy this. So take a look at all this algebra and come in tomorrow, and don't worry, we're definitely going to practice this. All right, see you tomorrow.